Hi, welcome to my topic Circuits and Networks. I am Ravikant Maladoshila, and today also we are going to discuss about maximum power transfer theorem, especially problems involved with dependent sources. So this particular video will be treated as class 2. As we have seen the basic definition of maximum power transfer theorem for DC networks, it states that maximum power can be transferred from source to the load when load resistance is equal to the source resistance. For this, we have seen an example of Thevenin's equivalent circuit where you have source voltage, source resistance, and load resistance. So according to the statement, when load resistance is equal to the source resistance, then the maximum power will be transferred. And what will be the value of maximum power? The maximum power will be Vs square by 4RL. So this we have seen already in the previous class. So let us go with the important discussion of dependent sources. Here you can see Va, which is situated over this RL, is known as voltage dependent voltage source, and we have to obtain its value, and we have to obtain the maximum power using the same theorem. So for that, what I'm going to do, first I'm going to remove the load from the given circuit. Then I'm going to find out open circuit voltage and R equivalent. The open circuit voltage is also called as Thevenin's voltage. R equivalent is nothing but Thevenin's resistance. So this is how the circuit looks like. We are going to remove the load from the given circuit, and open circuit voltage, which is called as Thevenin's voltage, that we need to find out here. After finding out the value of open circuit voltage, we can find the value of equivalent resistance. And after that, we are going to obtain the Thevenin's equivalent network, what we have seen in the previous slide. And then we are going to calculate the maximum power. Now for this, we have assumed the mesh analysis by assuming I1 in this loop, I2 in this loop. With clear inspection, you can see I1 is equal to 3 amperes because the direction of the source current here and the assumed current direction are one and the same. That is why I1 is equal to 3 amperes. Then we need to obtain the value of VOC. VOC, you can see it's the open circuit voltage measurement across 4 ohms. So this is nothing but 4 into the current which is flowing I2 will give you the drop across this terminal, and hence it becomes the open circuit voltage. And applying mesh analysis to the second loop where you need to know the value of I2. So I'm going to start with 4 I2 minus I1, the drop across this branch. Then you have voltage dependent voltage source. Now you can see VA has changed to VOC. Why? Because it's the open circuit voltage and it is the same terminal where we need to require the voltage measurement. So VA will be changed to VOC. Once this value is changed to VOC, and since this voltage dependent voltage source is depending upon VA, hence 0.5 VA changes to 0.5 VOC. So that is how we have replaced this value, and it is minus sign is on the left side, that's why it's minus 0.5 VOC plus 4 I2, 4 I2, this current, it is equal to 0. So this becomes loop 3. I'm going to substitute the values of 1 and 2 in equation 3. Then I'm going to obtain the value of I2, which is equal to 2 amperes. Once the value of I2 is obtained as 2 amperes from equation 2, I can easily obtain the value of open circuit voltage, which is equal to 4 into 2, that is 8 volts. So this is how we calculate the open circuit voltage across the terminal. I hope you understand this particular point, how we have estimated VOC. Now let us find out the short circuit current, because short circuit current is the current which is going to flow across this VOC. So you can see when shorted line is obtained from this point to this point, this short line is in parallel with 4, hence current will be trying to obtain to the least resistance path. So this 4 ohms here becomes dummy resistance. Once this becomes dummy resistance, this circuit changes to this circuit. Am I clear how we have changed it from this circuit to this circuit? First we have shorted the wire is shorted. When this is shorted, this path will go off. When this path will go off, this is how the circuit looks like. Now you can easily identify loop currents I1 and I2. But one thing you need to keep into your mind here, once this is shorted, the value of VOC becomes 0. When this becomes 0, VOC becomes 0. Naturally, you have to apply 0 volts across this particular point. So 0.5 multiplied with 0 becomes short wire. So hence, this voltage dependent voltage source will go off. So this will go off like this. This 0.5 multiplied with 0 becomes short. So this dependent voltage source is replaced by a short wire. Once this short wire is obtained, you can see this short value and this short value will dominate over this resistance. Hence, this becomes dummy in nature. In fact, ISC is nothing but is equivalent to 3 amperes. I hope you got this point. What we have done, we have just shorted the open circuit terminal. Then once it is shorted, the value of VOC is becoming 0. When this value is becoming 0, and since it has its dependency on voltage dependent source, so 0 multiplied with 0.5 becomes short wire. So voltage will be replaced by a short wire like this. So that is why this wire is connected like this. And once this circuit is formed, you can see this 4 becomes dummy in nature. In fact, the entire 3 amperes will be flowing across the closed path like this. And we can say ISC is equal to 3 amperes. Now once we are obtaining the value of VOC and ISC, just substitute the values. So we are going to obtain the value of R equivalent, which is also known as Thevenin's equivalent, equal to 8 by 3 ohms. Now once we have obtained the value of R equivalent, we need to substitute in the load. So R equivalent or R load, which is equal to 8 by 3. This resistance should be equivalent to source resistance in order to make the maximum power to transfer from source to the load. So RS is equal to 8.3. At this particular value, maximum power will be transferred. So that value is nothing but 8 square divided by 4 times load resistance or R equivalent. So 8 by 3, which gives the value as 6 watts. So this is the value of the maximum power which is flown from source to the load. Very important problem. You need to solve these kind of numericals in order to understand the concept in much more in-depth way. Now let us go with another example. Obtain load resistance. You can see there is a variable load resistance from maximum power transfer theorem. So we need to apply the theorem to obtain the value of load resistance. So for that, see, I have taken this main load out from the main circuit, and this is how the circuits look like. And here we need to find out open circuit voltage and later on R equivalent. So this open circuit voltage, it is parallelly placed to 20 ohms as well as 40 ohms in series with 50 volts. So in fact, VOC is measured over here. Is this clear? How we have shifted this V to this particular point? Now this becomes a simple circuit. We can apply KCL to obtain the value of VOC. So we are going to apply KCL here. That is the algebraic sum of the currents at a particular junction is equal to 0. So this 0.5 I1 current dependent current source, it is flowing towards VOC. That is why it is minus 0.5 I1 because it is flowing towards VOC. Then you have branch current VOC by 20. VOC by 20, and another branch current you have VOC minus 50 by 40. That is the value of I1. Is this clear? So equations 1 and equation 2 are framed like this from clear inspection. Now substitute these two equations in one another and try to obtain the value of VOC, which is equal to 10 volts. Am I clear? How we got the value of VOC as 10 volts? Right. Now let us calculate I short circuit. Now I short circuit, you have to just remove the load and we have to short here. We have to short here. When you're going to short here like this, here you're going to short the wire like this. Okay. Now this short wire has impact on this 20, so this 20 can be replaced. Okay. So this is how we do that. Then After shorting the wire, this 20 ohms goes off and we are left out with this circuit, this reduced network. Now you can see this 0.5 I1, it is coming towards this point node A, and short circuit is going like this. Already we know that I1 is flowing in 40 ohms in series with 50 volts. So applying KCL here. So I'm applying KCL. RGB sum of the currents at particular node is equal to 0. So since it's an input current, minus 0.5 I1 plus ISC. ISC it is going here, plus I1. I1 is also going here. It is equal to 0. Now I'm going to obtain ISC in terms of I1. That is ISC is equal to minus I1 by 2. Now what is I1 here? In the previous case, I1 is equal to VOC minus 50 by 40, and that we have treated as equation 2. That is for the open circuit conditions. Now for short circuit conditions, we have shorted the wire. So this VOC, whatever the value is there, it is not over here. So this is being made to 0. So you'll be having I1 is equal to minus 50 by 40. I1 is nothing but is 50 by 40 according to Ohm's law. So it becomes I1 is equal to minus 5 by 4. Now you can obtain the relationship between ISC and I1. And once the I1 is replaced in this equation, you're going to obtain the value of short circuit current, which is equal to 5 by 8 amperes. So this is a very important technique. I hope you understood. Now once the value of open circuit voltage is obtained, then short circuit current is obtained. Calculate the R equivalent, which is equivalent to VOC by ISC. That is nothing but 10 divided by 5 by 8. This 8 goes to the numerator. 5 2s are 10. Now 2 multiplied with 8 will give you the value of 16 ohms. So this is the value of R equivalent or load resistance, which should be made equivalent to the source resistance. Then we can obtain the maximum power, which is equal to 10 square by 4 into 16, which is nothing but 100 by 64, which will give you the value as 1.56 watts. So this is how we solve the problems involved with dependent sources for maximum power transfer theorem. So if you like my video, please share among your friends, and please subscribe to my channel and press the bell icon for the future notifications. Thank you.